Thank you for the introduction, and thanks also again to be able to talk here and to introduce our work for the determination of the biogenic CO2 emission, and with that also to be able to calculate the part of green energy which can be generated by waste incinerators or refuse-derived fuel plants. If we look on the legal aspects, there are two drivers, motivation drivers for such kind of measurements. One legal requirement are the greenhouse gas emissions. So to meet the requirements of the Kyoto Protocol and to reduce the greenhouse gas emissions. So as a part of the European Green Deal, the Commission proposed in September 2020 to raise until 2030 the greenhouse gas emissions reduction to at least 55% compared to the level of 1990. So it's quite interesting and good goal for the future. If we look on the other driver, if we look on legal aspects, this is the renewable energy part. So here it's important to be in compliance with the targets set by the European Union in the Directive 2080-21 on the promotion of the use of energy from renewable sources. So there's also a new target now for the member states that until 2030, at least 32% of the produced and consumed energy should be from renewable energy sources. So that's also, once again, an important goal. However, on July 14 last year, there was also a new proposal of the European Commission under their program Fit for 55. And there it's fixed now, or it's a new proposal to increase this part of renewable energy sources up to 40% until the year 2030. So the, let's say, wishes or the requests are getting quite stronger. Biogenic CO2 emissions are considered to be greenhouse gas neutral. And then it's a question why, because normally we can say CO2 is CO2. So, but for that we have to look on what we call the biogenic carbon cycle. So there exist old fossil carbon from petroleum, coal, which was stored for millions of years when this material was generated. And with the industrialization, this oil and coal was exploited and then was used and processed. And at the end, it's disposed upon combustion. And then the carbon is released in form of CO2. And by the accumulation of this CO2 in the atmosphere, this is a big part of the greenhouse gas effect, which leads to the global warming. A part of this released CO2 surely is absorbed by the plants. And also plants are used for different ways. The easiest ways in earlier time also for heating, but we also have processing. So once again, it's a cycle, but also this is disposed under combustion, and once again CO2 is generated and it's also released to the atmosphere. So, but once again, a part of this CO2, of the global CO2, is absorbed by the plants, and this cycle, it's called the biogenic carbon cycle, and it's considered as greenhouse gas neutral. So because by burning plants and trees and so on, only CO2 is released, which was absorbed by these trees and plants in the last couple of years. So it's not like a new CO2 which is released by burning coal or oil, like in the other case, which is then called the fossil CO2. So, and that is the reason why we have to determine, or why is there interest to determine the biogenic CO2. If we look on waste incineration or also on RDF plants, and we look on the fuel, we have a different kind of fuels, like it's showed here in the picture. There's household waste, tires, green waste, wood chips, hazardous waste. So it's quite difficult to determine what is green and what is not green. So, and once again, there, if you look for the legal requirements, if in the directive there's mentioned that energy from renewable sources means energy from renewable non-fossil energy sources, including but not limited to biomass. And because it's so difficult to determine, or it was difficult to determine by such waste incineration or RDF plants, the biogenic content, there are several regulations. For example, in Germany and France, it's defined 50% of the generated energy from such plants is biogenic, and 50% is fossil. So these were estimations done by some work some years ago that they fixed these values. But in the reality, the biogenic portion of the waste fraction which is used could vary by the plant, but also over the year. It could be different if you are looking in winter time or in summertime. So it makes sense to determine plant-specific biogenic proportions. And if we consider that, let's say, or if we could demonstrate that the biogenic portion of the generated energy is more than 50%, as it is used today as fixed value, that could be an additional help to achieve the new target for the renewable energy. So this could be a help for the authorities or for the government, but it could be also a possibility if such plans would be implemented in the greenhouse gas trading to save for the operators greenhouse gas certificates. So if we look on the different ways how to determine this biogenic CO2 portion, there's one way is to make an input control. So what is done there? There's from time to time taking some grams of the waste or of the fuel, and then it's analyzed. And then we have, let's say, some result. But you can imagine at first it's time intensive and due to the character of random samples. So there's an analysis of a few grams of tons of materials. There's a quite high uncertainty due to these systematic limitations. Another possibility is a standard which was already published as ISO and EN. It's a 13833, which is continuous sampling of a part of the flue gas on a CO2 adsorber material, followed by an analysis of the sampled CO2 with the carbon-14 method. So if we look then, carbon-14 method, what is that? How this can help? A short explanation here. So in the atmosphere, we have nitrogen-14, and with the beta rays of the sun, it's generated carbon-14. This combines with the oxygen to CO2, and this is carbon-14 CO2. This is accumulated by plants, but also by animals, by us, by human living. And after the death, this carbon-14 is converted again in nitrogen-14 in energy. So this means the carbon-14 concentration decreases with increasing age. So the half value period for that is 5,700 years. So this means fossil material and therefore fossil fuel does not contain any carbon-14. So in the other way, by the incineration of fossil fuel, no carbon-14 CO2 is generated. And with the determination of the carbon-14 fraction of the emitted CO2, it's therefore possible to determine the fossil fraction, and with that the biogenic fraction of the burned fuel. If we look on the principle, it's extractive sampling. And the extraction is done under volume proportional conditions. So we have a heated probe for that. After that, it's a heated line, and then it's such a controller box. Here, the sampling is controlled, start, stopped. The volume proportional extraction is done. The volume, which is going over the adsorber cartridge, is measured. The CO2 is adsorbed in a trap or cartridge, which is filled with ascarate or soda lime. We can realize sampling periods of several hours until 1 month. So with that, you can imagine we can realize continuous sampling of the flue gas, and with that continuous sampling and determination of this biogenic CO2 content. Only to mention that all the technologies we use here in this system, which we call AMESA B for biogenic, is adapted version of the well-known AMESA D, which is used for dioxin sampling since more than 25 years, and the AMESA M, which is also used since more than 10 years now for the mercury sampling. Here we have pictures on the left side. You see the heated probe on a horizontal flue gas line. with the heated line, and on the right side you see the cabinet, so that you have an idea what kind of size we are talking about. In France, we had a project and participated with that. It was called the UIOM 14C project. The idea was the determination of the biogenic CO2 portion and the green energy over 1 year at 10 municipal waste incinerators and 1 RDF plant. So these plants correspond to about 10% of the total amount of the burned waste in France. So it's a quite representative sampling in these 10 plants. For the calculation of the biogenic fuel and fossil fuel and the green energy was used software or calculation program, which is called MassBio, which is a patented software from Cabinet Merlin, which was one of the project partners. The others were ADEME and FNAT, and we as the supplier of the AMESA B system. In total, were taken 148 samples from incineration plants and 10 samples from the RDF plants. If we look now on the results, at first, it could be determined in average that 58% of the CO2 which was emitted was biogenic, and 42% of it was fossil CO2. Back calculated to the fuel, it could be seen that fossil waste was around 19% and biogenic waste 67% and non-combustible were around 14%. And with that could be calculated a renewable energy portion of 55%. So as you can see, it's already more than this 50%, which is used today as a fixed value. On the other side, operators of waste incinerators have no direct influence of the used fuel. So this can be only done by the sorting and sampling before it's delivered to the incineration. So then we're also done calculation. Okay, what would happen if we reduce the fossil waste fraction by 10%? By the calculation, it could be shown that this will generate an increase of the biogenic CO2 fraction in the flue gas by approximately 20%. And with that, the green energy part could be increased from 55 to 77%. So this demonstrates it could be quite helpful to have a better sorting before the incineration to increase this green energy part of waste incineration. With that, I come to the conclusion. The results presented demonstrate that the currently common assumption of 50% green energy from such waste incinerators and RDF plants could be an underestimation. And with that could be quite interesting to determine the biogenic fraction quite more frequently. With the application of the EN ISO 13833 by long-term sampling, with, for example, such an AMESA B system, it's an easy tool for the determination of the biogenic fraction. So let's say the excuse to use a fixed value because it's quite complex to determine this biogenic fraction is not really valid anymore. It's quite good and suitable method for the determination of that. So should in future further plans be included in the greenhouse gas certificate rate, this is already done in Denmark and Sweden, the determination of the biogenic CO2 fraction with the presented method can be a financial advantage also for the plant operators. So today in Europe, the most incineration plants are not yet implemented in this greenhouse gas trading. Nevertheless, in different countries, there are discussions about it. So could be also a tool for operators to save money in the future. So for that, I come to the end. I thanks for your attention. I hope it was interesting for you. And we have also virtual booths here, so you can come there and visit us or to visit our webpage or to contact me directly. Or if you have any questions, we have later, I think, a question and answer session. Thank you.